Welcome everyone to 10 Minutes Math. This is Edexcel Mechanics M2, January 2019, WME0201. Let us start first question. 3 particles of mass 3m, m, and 2m. So we have 3 particles. This is the first one, 3m, and this is the second one, m. And this is the third one, 2m, and this one, 3m. Positioned at the point with coordinates a and 8. So here a and 8. Here the position -4 and 0. Here this position is 5 and -2, respectively. Given that center of mass of the 3 particles is at point coordinate k and plus k, so center of mass is equal to k and 2k. Now, where k is constant, find the value of a. So you're looking for this a. Okay, let us start to solve this question. So to solve this question, we have one equation which is mass multiplied by position plus mass multiplied by position plus mass multiplied by position will equal to the total mass multiplied by the center of mass. So let us start to solve. We have the first particle is 3m, so 3m multiplied by the first position a and 8 plus m, the second position -4 and 0, plus the third one 2m multiplied by 5 and -2 will equal to summation. We have 3 plus 1 4 plus 2 6, so 6m multiplied by k and 2k. Let us write the equations. So 3ma minus 4m plus 10 is m will equal to 6mk. Let us write the second equation. 24m plus 0 minus 4m will equal to 12mk. So from the second equation here, m goes m, so 24 minus 4, 20 will equal to 12k, so k was equal to 20 divided by 12 was equal to 5/3. Now let us go to the first equation. M goes m, so the first equation 3a minus plus 6, 3a plus 6 will equal to 6k. So 3a plus 6 will equal to 6 multiplied by 5/3. So divided by 3, here equal to 1, here equal to 2, so it will equal to 10. So 3a plus 6 equal to 10. 3a equal to 10 minus 6, so equal to 4. So a is equal to 4 divided by 3. And this is your answer. Okay. Let us start the second question. A particle of mass 0.75 kilogram is moving with velocity. So I have a particle. This particle is 0.75 kilogram moving with velocity 4i. So he moved in this direction. Let us assume this direction. 4i plus j meter per second. When it's receive an impulse, so he receive impulse, this I is equal to minus 6I plus 4J and S. Find the velocity of the particle immediately after receive the impulse. So again, this is the impulse. Now this is U, and here will be V. Okay, so let us find now V. So this is part A. We know that I is equal to mv minus U. So I minus 6I plus 4J will equal to 0.75. Here multiplier by V is equal to V, I don't know, V minus U, which is 4I plus J. So now let us divide it by 0.75 and divide it here by 0.75. So 6 divided by 0.75, 6 divided by 0.75 will equal to 8. So minus 8I plus, let us divide, 4 divided by 0.75, 16 divided by 3, 16 divided by 3J will equal to V minus 4I plus J. So now this 4 come here positive, so it will be 4 minus 8 plus 4 in I plus 16 divided by 3 plus 1 in J equal to V. So V now is equal minus 4I plus 3 over 3 plus 16, 19 over 3G. And this is the velocity immediately after impulse. Okay, now the size of the angle through which the path of the particle is deflected as a result of the impulse. So now let us find the theta after impulse. So this is part B. So we have V is equal to minus 4I plus 19 over 3G. So theta, let us draw the triangle. If this is our theta, so I have theta here 4 and here 19 over 3. So theta would equal to tan minus 1, 19 over 3 divided by 4, so it will equal to 10 minus 1, 19 divided by 12. And this is the theta, the first theta. U is equal to, from the start, U here, 4I plus J, 4I plus G. So again, this is alpha. So here 1, here 4, and here 1. So alpha is equal to tan minus 1, 1 over 4. Now, the deflection. So now angle is equal to 180 minus 10 minus 1, 1 over 4 minus 10 minus 1. The upper angle is 19 over 2, 19 over 12. 19 over 12. So now angle is equal to, let us start to find this angle, 180 minus shaft tan 1 divided by 4, close the bracket, and minus shaft tan 19 divided by 12, close the bracket. So the angle is 180.24, 180.24 degree. And write the angle now. Angle is equal to 180. Okay, let us go ahead to another question. Start to read. A car of mass 900 kilogram is moving on a straight road that is inclined at the angle theta to the horizontal, where theta is equal to sin theta equal to 1 over 49. So I have now, this is the road and this is theta, when sin theta is equal to 1 over 49. I have a car here. This car has mass here mg, which is 900 g. So this force I can now divide into here. I can add here this value 900 g sin theta. When the car is moving up to the road, so the car is moving up, so this is the acceleration. With the engine of the car working at a constant rate, so we have here the car engine, which is 10.8 kilowatt, and the car constant speed is v, so we have velocity v. The resistance motion of the car from non-gravitational force is modeled as a constant force magnitude r. So I have here this is it, the direction of the motion, so this is the direction of the resistance r. Now when the car is moved down the road, so let us now start to draw the second part. This is again theta. Now the car is moved down, so this is what? This is A now. And we have the same force, which is here, 900 g sin theta. When the car is moving down the road with engine of the car working at a constant, the same power here, 10.8, so I have here 10.8 kilowatt. The car has a constant speed. The resistance here change, so the resistance here will be r, and the constant speed 2v, so this motion here 2v. The resistance to the motion of the car still modeling as a constant force magnitude r. Find the value of r. So I have two cases here. This is up and this is down. Let us start one by one. So for down, I have P is equal to FV. So now, so 10.8 multiplied by 1000 is equal to F multiplied by 2V. Now, and the equation of the motion is for down, I have r minus 900 g sine theta will equal to f. Okay, and the second one here, the second one when we go up, now again v is equal to fv. So 10.8 multiplied by 1000 is equal to fv. Here the equation again will be r plus 900 g sine theta will equal to f. Okay, so this equation I have, let us write now the two equations. R minus 900 g sine theta is equal to 10.8 multiplied by 1000 divided by 2v. The second one, r plus 900 g sine theta is equal to 10.8 multiplied by 1000 divided by v. Let us subtract the two equations. So this one minus this one in this direction. So now this r will go with this r, and we have 2 multiplied by 900 g sine theta is equal to here half multiplied by 10.8 multiplied by 1000 divided by v. So from here v is equal to 0.5 multiplied by 10.8 multiplied by 1000 divided by 2 multiplied by 900 multiplied by 9.8 multiplied sine theta is equal to 1 divided by 49. Let us find v. 0.5 by 10.8 by 1000 divided by 2 by 900 by 9.8 divided by 49. So the velocity is equal to 15 meters per second. 15 meters per second, and this is the velocity. Let us now start to find the r. Any of this equation, r is equal to the 108. Let us go to the first equation. We have r minus 900 multiplied by g sine theta is equal to 10.8 multiplied by 1000 divided by 2v. This is equation number 1. This is equation number 1. So let us find now r. R is equal to 10.8 multiplied by 1000 divided by 2 divided by 15 plus 900 multiplied by 9.8 divided by 49. So 540, this is r. 540 Newton, this is r. Okay, let us go ahead to another question. Find the value of v. We find already v. So this is v. This is part b. And this is part a. Okay. Let us go ahead to another. So the uniform lamina L shown in figure 1, shaded in figure 1, is formed by removing a circle distance of radius 2a. So we have circle radius 2a, the one here white. From the uniform circle distance of radius 4a. So this is the origin and this is the big one 4a. The large disk has a center O and diameter AB. The radius OD is perpendicular to AB. The similar disk has a center C, where C is on AB and BC is equal to 3A. Show that the center of the mass of L is 13 divided by 3A from B. First circle, which is the big one, the area of this circle will be pi r squared. So the big circle, let us start to solve this part. This is part A. Big circle, big is equal to the area pi r squared, so pi 4a squared. Now the distance from, this is the center, the distance from A is equal to this distance from here to here, 4a. So distance 4a, and the distance from A, distance D from B is equal to 4a. Small area is equal to again pi r squared, so it will equal to pi. Now the radius of the small one, here is 2a. So 2a squared, and dB will equal to the distance from the center to B is 3a. So let us now find the center. We have the area, which is 16 by a squared multiplied by the distance, which is 4a, will equal to minus here is the small one. The small one is 4 by a squared multiplied by the distance, which equals 3a. Okay, will equal to, now the area, a squared hereby minus 4a squared multiplied by xb. So let us remove the pi and a squared and pi. Here also is squared, here is squared. So, and pi. So I have here 16 multiplied by 4, and a will be outside, minus 4 multiplied by 3 will equal to 12xb. So xb now will equal to 16, let us open the bracket, 16 multiplied by 4 minus 4 multiplied by 3 divided by 12. So xb is equal to, yes, 13 divided by 3a. And this is the answer of the first part. Let us go ahead. The mass of L is m, and the particle of the mass km is attached to L at B. So let us now start to add. I have mass here km at B. km. And I have a distance from here at 13 over 3a, we have the m. The the mass of the particle. With the particle attached is freely suspended from the point D, it hangs in equilibrium with A higher than B, and AB at the angle of theta to the horizontal, where theta is equal to 3/4. Find the value. This is part B. This is how it looks like your rod. This is 4A and this is 4A. This distance 4A, so this angle now is 45. And this part is 4 square root of 2A, this line. And I have mass here, which is the mass of the rod with this distance, which is 13/3A. And this part I can now start to make this component, which if this one angle theta, so this component will be m cosine theta. And this component has distance now total from B is equal to 13/3A. So let us take now a moment about B. So we have this force, which is m cosine theta multiplied by the distance 13/3A. We don't have any other force, so this moment will be equal to the summation of, we have here also another force here, Km. The summation of the force will be equal to m plus Km multiplied by the free distance. Let us see, this is the equilibrium that it will be free at D. So the distance of the summation of the mass will be this distance. So multiplied by x bar. X bar divided by 4 square root of 2A is equal to cosine 45 plus theta. 45 plus theta. So x bar now is equal to 4 square root of 2A cosine 45 plus theta. So I can start to write the equation now. M A cosine theta multiplied by 13 divided by 3 is equal to m k plus 1 x bar is equal to 4 square root of 2 a cosine 45 plus theta. Okay, now he gives us in the question, let us remove a and m, and here m and a. So let us draw the triangle of theta. He said that in the question that tan theta is equal to 3/4. So this part will be 5. So let us now write the equation. Cosine theta is equal to 4 divided by 5 multiplied by 13 divided by 3 is equal to k plus 1 multiplied by 4 square root of 2 cosine 45 plus theta. From here I can set that theta is equal to tan minus 1 3 divided by 4. So 36.87. This is theta. So let us find now k. So k is equal to, now cosine Now answer plus 45 will equal to 0.14. So now 4 divided by 5 multiplied by 13 divided by 3 divided by, and then open the bracket, 4 square root of 2 multiplied by answer. So now this is k plus 1 minus 1, so k is equal to 10 over 3, 10 over 3, and this is your answer. Okay, let us go ahead to another question. A particle moves along the x-axis at time t second, t bigger than or equal to 0. The velocity of the particle is v meter per second in the direction of x increasing, where v is equal to, so v is equal to 2t power 3 over 2 minus 6t plus 2. At time t equal to 0, the particle passes through the origin. So at t equal to 0 distance, or he passes through the origin. At the instant when the acceleration of the particle is 0, so acceleration is equal to 0. The particle is at the point A, so he starts at O and finish at A. Find the distance OA. He needs the distance OA. So dv by dt is equal to the acceleration, and integration of v dt is equal to the distance A OA. Okay, let us find first the acceleration. So dv by dt A is equal to dv by dt is equal to 2 multiplied by 3 over 2 t 3 over 2 minus 1 minus 6. So the acceleration was equal to 2 3 t power half minus 6. At A, acceleration is equal to 0 at point A is equal to 0, so 0 is equal to 3t power half minus 6. So 6 will equal to 3t power half. So from here 2 will equal to t power half. So t is equal to 4 seconds. T is equal to 4 seconds. Now let us find now the integration to find the distance. Integration of v dt is equal to the integration of 2t power 3 over 2 minus 6t plus 2 will equal to 2 multiplied by 1 over 5 over 2 t 5 over 2, which is 3 over 2 plus 1 minus 6 divided by 2t squared plus 2t plus c. C here is a constant. At origin, at t equal to 0, s equal to 0, and so s, which is this equation, is equal to 0. So s, which is equal to 4 divided by 5, t 5 over 2 minus 3t squared plus 2t plus c. T equal to 0, s equal to 0, so c equal to 0. So now let us find the s, which is the distance at 4 seconds, is equal to 4 over 5 multiplied by 4 power 5 over 2 minus 3 4 squared plus 2 multiplied by 4. So S equal to, let us find the distance, 4 by 5 multiplied by 4 power 5 divided by 2 minus 3 multiplied by 4 squared plus 2 multiplied by 4. So the distance is equal to minus 14.4 minus 14.4. So the distance D OA is equal to 14.4 meters. This is your answer. Okay. A blank AB rested in equilibrium against a fixed wall, horizontal wall. The blank has length 4 meter, weight 20 Newton, and rest on the wall at C, where AC is 2.5. The end A of the blank rests at rough horizontal ground, and AB makes an angle of theta. So I have a friction here. So this is F, and the coefficient of the friction between the blank and the ground, mu, is equal to 1/4. The blank modeled as a uniform rod. So uniform rod, so I have mass here, which is 20 Newton, and this distance here is equal to 2 meters. So I can now start to divide this force into one force here, 20 cosine theta, and another perpendicular one here, this is theta, so 20 cosine theta. The blank model as a uniform rod, and the wall has as a rough horizontal peak that is perpendicular to the vertical plane containing AB. So I have here friction of wall. So friction of wall, here this wall. So let us add wall. And I have, given that theta is equal to cosine theta 4/5, and the friction limited in both A and B, find the magnitude of the normal reaction at C. So he need here NC. He has here NC. This is the one he need. We have here also NA. Okay. This force here, I can now start to add one magnitude here, and another magnitude is here, which is F sine theta. F sine theta. Okay. Let us start to solve this question. So he needs NC, so this is A. So he needs NC. Let us take the moment about A. So moment about A. And I will take the direction of NC is positive. So I have NC multiplied by the distance, which is 2.5. So this is NC multiplied by the distance to A, which is 0.5. So NC multiplied by 2.5, and this is positive. Negative, because the component of the weight, which is 20 cosine theta, make negative moment. So 20 cosine theta multiplied by 2. So negative 20 cosine theta is equal to multiplied by 2 is equal to 0. So let us now draw the triangle. This is theta. He said that cosine theta 4 over 5, so this will be 3. So NC will equal to 20 multiplied by 2 multiplied 4 over 5 multiplied by 1 over 2.5. So NC was equal to, let us start to find the NC, 20 multiplied by 2 multiplied by 4 divided by 5 divided by 2.5. So NC was equal to 12.8. So NC is equal to 12.8 Newton. This is the answer of the first question. Find the coefficient of the friction between the blank and the pool. So you need to find the coefficient of the friction here, mu, between the blank and the pool. Let us assume here we have the friction. So this is the reaction R, and this RC has component here NC, and this angle will be theta, NC cosine theta, and we have horizontal here. So here NC sine theta, NC sine theta, and also the component here of this F, I have component here horizontal, and this angle is theta, so I have F pool cosine theta, and I have here vertical F pool sine theta. So let us now start to solve. This is B. Sigma F of X equals to 0. What is the force we have in X? We have F, which is this direction positive, and we have, this is the positive value, and we have F pool cosine theta, and this is positive value, and we have the NC sine theta, and this is negative value. So this is the total force that we have in the X direction. Again, F, which is this force, positive, plus F pool cosine theta will equal to NC sine theta. So let us write this equation. F plus F pool cosine theta will equal to N sine theta, NC of course. Now, so F will equal to the NC 12.8 multiplied sine theta 3 over 5 minus F pool cosine theta, which is 4 divided by 5. And this is the first equation that we have. This is the first one. The second one, F sigma F of Y equal to 0. What is the force that we have in Y? The force we have in Y is R plus F NC cosine theta plus F pool sine theta will equal to minus 20, which is this 20, minus 20. So let us now write this equation. We have R plus NC cosine theta plus F whole sine theta is equal to 20. So from this equation, R is equal to 20 minus NC cosine theta 12.8 multiplied by cosine 4/5 plus F minus F whole multiplied by sine theta, which is 3/5. So R now will equal to, let us start to find this value, 20 minus 12.8 multiplied by 4 divided by 5. So will equal to 9.76 minus 0.6 F whole. And this is the second equation that we have. Okay, so we have, this is the first one and this is the second one. We know that F is equal to mu multiplied by R. So F is equal to mu multiplied by R. So it will be 1/4 multiplied by 9.76 minus 0.6 F whole. Okay, so now let us start to write 1/4 multiplied by 9.76 minus 0.6 F whole will equal to, let us go ahead to the first equation here, 12.8 multiplied by 3/5. Let us find this value. 12.8 multiplied by 3 divided by 5 will equal to 7.68, equal to 7.68, and here minus 0.8 F whole, minus 0.8 F whole. From the first equation, let us start to find the F whole. 9.76 minus 0.6 F whole is equal to 7.68 multiplied by 4 equal to 30.72 minus 4 multiplied by 0.8, 3.2 F whole. So F whole now is equal to 3.230 point, let us open the bracket, 30.72 minus 9.76 divided by 3.2 minus 0.6. So 8.06, this is 8.062, 8.062, this is the F whole. Now we know that F whole is equal to mu multiplied by NC. So now mu is equal to F whole 8.062 divided by 12.8. So mu will equal to 8.062 divided by 12.8. So mu will equal to 0.63. So mu 0.6298. So mu will equal to 0.63, and this is your answer. Okay, let us go ahead to another question. A particle B of mass 3m, so we have particle B, this is B, 3m, is moved in a straight line with a speed u on a smooth horizontal table. So here I have u. A second particle q has mass 2m, so I have here q and the mass is 2m, is moving with the speed u in opposite direction, so has the speed here 2u. Opposite direction to B along the same straight line. Particle B collide directly with Q. The coefficient of the distribution between B and Q is E. Show that the direction of the motion B is reversed as a result of the collision of Q. So let us start E. This is part A. E is equal to VQ minus VB divided by the two speed u plus 2u. So this V is equal to VQ minus VB divided by 3u. Now from the motion 3m mv, let us write the equation of motion. We have m u b plus m u q will equal to m v b plus m v q. So we have 3 m u plus 2m minus 2u will equal to 3m VB plus 2m VQ. So let us remove m with m with m with m. So I have 3u minus 4u is equal to 3VB plus 2VQ. So minus u will equal to 3VB plus 2VQ. So let us now find from the first equation up here. From the first equation here, VQ is equal to E multiplied by 3U plus VB. So let us write this equation now. Minus U is equal to 3VB plus 2, 3EU plus VB. So minus U is equal to 3VB plus 6EU plus 2VB. So we have minus U minus 6EU will equal to 5VB. So now let us take the U here. So U minus U 1 plus 6E is equal to 5VB. So VB is equal to minus U over 5, 1 plus 6E. So now this is minus, so VB will change direction. Okay, so let us now go to the second part. Find the range of values of E where which the direction of the motion of Q is also reverse as a result of collision. The Q is reverse motion the reverse direction of the motion. So VQ will be bigger than 0. VQ is equal to 3EU plus VB. So we can write now 3EU plus minus U divided by 5 multiplied by 1 plus 6E is bigger than 0. So 3U minus U over 5 minus 6 over 5EU bigger than 0. So 3EU minus 6 over 5 EU is bigger than U divided by 5. This part gives us 9 over 5. EU is bigger than U over 5. This 5 is this 5, U is this U. So E is bigger than 1 over 9. So the final answer here for the range of E is less than or equal to 1 and bigger than 1 over 9. Okay, this is the range of E. Let us go ahead to the another part. Find in term of M if given that E equal to half. Given in term of M and U, the kinetic energy lost in the collision between B and Q. Let us start to solve this question. This is C. We need the kinetic loss. So let us start again the same equation. We have VQ minus VB divided by U plus 2U is equal to half. So VQ minus VB is equal to 3U divided by 2. So VQ is equal to 3U divided by 2 plus VB. Again, the equation, this is the first one. The equation of the motion that we write it before, 3mu plus 2m multiplied by minus 2u will equal to 3mvb plus 2mvq. So 3u minus 4u is equal to 3vb plus 2 multiplied by 3u divided by 2 plus vb. We remove mass. So here I have minus u will equal to 3vb plus 3u plus 2vb. So vb from this equation, vb will equal to minus 4 over 5u. And VQ will equal to 3u over 2 minus 4 over 5u will equal to 7 over 10u. The kinetic loss is equal to half m ub squared minus vb squared plus half m again and uq squared minus vq squared. So it will equal half u squared 3m. So we have here ub squared, which is 1u squared, so 1 squared minus 0.8 squared plus half multiplied by 2m multiplied by u squared, and then vq squared, which is uq squared, it's 2 squared minus 0.7 squared. So let us continue. We have 3 over 2 u squared, 1 minus 0.64 plus this part, it goes this part, so it will be u squared 4 minus 0.49. So now will equal to, here I have m, here I have m. So it will equal to 3 over 2 mu squared, here multiplied by 0.36 plus mu squared, here multiplied by 3.51. Let us find the final answer. So it will equal to 4 minus 4, 0.49, 3.51 plus 0.36 multiplied by 3 divided by 2. So it will equal to 4.05 mu square joule, and this is your answer. This is your answer. Let us go ahead to another question. A rough ramp AB fixed at horizontal ground at A. The ramp is inclining at 20 degrees to the ground. The line AB is the line greatest slope of the ramp, and AB is equal to 6. The point B at the top of the ramp, as shown in figure 3. A particle B of mass 3 kg is projected with speed 15 meters per second from A toward B. So if this is our particle B, so this is the direction of the motion, this is A, and the mass here will equal to the mass of the particle is 3g projected with, and the speed v is equal to 15 meters per second. The force due to the friction modeled as a constant magnitude F Newton. So let us add the forces now. We have here, that is the direction, so we have the friction here, and this two force can be divided into one here. This is theta, so 3g cosine 20, and I have here 3g sine 20, and I have perpendicular reaction here, which is R. Use work energy principle to find the value of F. Now change in kinetic energy will equal to half mu squared minus v squared. So it's equal to half multiplied by 3 multiplied by u is 15 squared minus 10 squared. So it will equal to 0.5 multiplied by 3, open the bracket, 15 squared minus 10 squared. So it's equal to 187.5. 187.5 joule. Now GBE is equal to mgh is equal by 9.8 by sine by 6 by sine 20. So it will equal to, let us find the solution, 3 by 9.8 by 6 by sine 20. 0.33 joule. In opposite direction against friction is equal to h multiplied by f 6f. So now we can write now 187.5 is equal to 6f plus 60.33. So f was equal to, the fraction will equal to this part, 187.5 minus answer will equal to, divided by 6 will equal to 21.2. So the friction was equal to 21.2 Newton. And this is the answer that you need. Let us go ahead to another part. After leaving the ramp at B, the particle moves freely under gravity until it hits the horizontal ground at point C. The speed of B as it hits the ground at C is W meter per second. Find the value of W. To write the energy equation, energy will equal to 1/2 multiplied by half m W squared will equal to half multiplied by m multiplied by the u is 10 squared plus 3 multiplied by 9.8 multiplied by 6 sine 20. So 3/2 W squared is equal to 3/2 multiplied by 100 plus 3 multiplied by 9.8 multiplied by 6 sine 20. So from here W is equal to, let us find W. So 3 divided by 2 multiplied by 100 plus 3 multiplied by 9.8 multiplied by 6 multiplied by sine 20 will equal to, multiplied by 2 divided by 3 will equal to square root of answer. So 11.84, this is W, 11.84 meter per second. So this is the speed of the particle. Okay, now let us go ahead to the another part. The direction of the point B as it hits the ground at C. So you need alpha. So this is part C. Now I have the particle, this particle under horizontal speed, which is 10 cosine 20, and under vertical speed, and the summation of them is W. So I can find now the angle if I draw like this. So this will be alpha. So cosine alpha is equal to 10 cosine 20 divided by the W, which is 11.84. So alpha is equal to, let us find the alpha, 10 cosine 20 will equal to divided by 11.84, shift cosine minus 1 answer. So alpha 37.5 degree. This is the angle of the particle when he hit the ground. Okay, let us go ahead to another question. Now, the greatest height of V above the ground as B move from A to C. So he need H in part C. We need H. We know that H is equal to V squared divided by 2G, where V is the vertical component of W. The vertical, so W sine alpha squared divided by 2G. So H is equal to, W is 11.8 multiplied by alpha is 37.5. So 11.84 multiplied by sine 37.5 divided by 2G. So H is equal to, let us find the H. So 11.84 multiplied by sine 37.5, close the bracket square, divided by 2 multiplied by 9.8. So H is 2.65. 2.65. This is your H meter. Okay. This is the end of this exam. Good luck. Bye.